Welcome to this explainer. We are jumping straight into a delightfully fizzy scientific mystery today. You know the drill. When a bath bomb hits the water, it instantly erupts into those incredibly satisfying gas bubbles. But what exactly causes that to happen? Today, we're breaking down the science behind the fizz. We're going to conduct an investigation, dig into some empirical data to pinpoint exactly which substances cause this effect, and then apply some scientific reasoning to figure out if that gas is an entirely new substance.
To solve this mystery, we first run into a bit of a wall. If you take the individual ingredients of a bath bomb, stuff like baking soda, Epsom salt, citric acid, or cornstarch, and mix them with water all by themselves, absolutely nothing happens. No reaction, zero bubbles. So, we've got to put on our detective hats. Our driving question is, what specific combination of these substances is the actual culprit producing the gas?
To figure this out, we need to conduct an investigation to get some hard data. And you don't need a high-tech lab for this. An ordinary household ice cube tray is honestly the perfect tool for a cross-matrix combination test. By mixing water and different bath bomb ingredients in each little compartment, we can methodically test pairs against each other. It's an elegant, super organized way to isolate our variables.
Now you might be wondering, just how many tests are we talking about here? Well, the magic number is 81. By crossing our 10 ingredients against each other in a grid and intentionally skipping the oils since they don't mix into a water solution anyway, we generate a matrix of up to 81 possible testing combinations. That is a ton of empirical data to hunt through. But it's exactly this kind of rigorous testing that lets us find genuine scientific patterns instead of just guessing.
Section 1. Analyzing the bubble data.
Let's fast forward to the results. Check out this 9x9 data matrix. Almost every single intersection is totally blank, meaning no reaction happened. But wow, a pattern instantly jumps out at the baking soda row. As you can see, baking soda produced a gas only when mixed with water and 3 very specific ingredients. Everything else, completely flat.
Let's zoom in on those positive results. The combinations causing bubbles were baking soda and citric acid, baking soda and sugar-free lemonade mix, and baking soda and sugar-based lemonade mix. Baking soda is the obvious common denominator here. But seriously, what on earth connects pure laboratory-grade citric acid with 2 completely different types of store-bought lemonade mix?
To crack this part of the case, we have to look beyond our ice cube tray. We need to cross-reference our experimental data by simply checking the ingredient lists on the back of those lemonade mix packages. Remember, a lemonade mix is exactly that, a mixture of several different substances. We need to find out what's hiding inside those packets.
And there it is. The empirical evidence gives us our hidden link. Citric acid is a primary ingredient in both the sugar-based and the sugar-free lemonade mixes. The other ingredients, like the sugar or the artificial flavors, are totally irrelevant. They're just innocent bystanders. The active player causing the effect is the citric acid.
Section 2. Constructing the argument. Now that we've isolated our culprits, it's time to build a rock-solid scientific argument based on the patterns in our data. We start with our claim. Only the combination of baking soda, citric acid, and water causes the gas. Next, our evidence. Our testing matrix showed bubbles exclusively in these specific combinations and nowhere else. Finally, the reasoning. We know the lemonade mixes worked because they both share citric acid as a key substance. It's a perfect loop of logic. We've successfully determined exactly what causes the effect.
Section 3. A brand new substance.
But hold on, we're only halfway through our mystery. We know exactly what caused the gas to form, but what actually is it? Is it just the baking soda, water, or citric acid floating up into the air? Let's apply some scientific reasoning to our evidence to co-construct an explanation here. Did those ingredients just change shape, or did they combine to create a brand new substance that wasn't there before?
To answer this, we have to lean on a key model idea in science, the concept of a property. A property is a fundamental characteristic of a substance that simply does not change. For example, a substance's state of matter at room temperature, whether it naturally exists as a solid, a liquid, or a gas, is a locked-in property. It's like a reliable fingerprint for that specific substance.
And this brilliantly illustrates our proof. Just look at the properties of what we started with compared to what we ended up with. Our starting ingredients at room temperature were baking soda, which is a solid, citric acid, also a solid, and water, a liquid. But our resulting effect, the bubbles, is filled with a gas. The logic here is undeniable. We put solids and liquids together and a gas came out. Which brings us to our grand conclusion. Because we know that fundamental physical properties cannot change, we can state for a fact that this gas cannot possibly be the baking soda, it cannot be the citric acid, and it cannot be the water. Baking soda doesn't just magically become a gas at room temperature. Therefore, those original substances interacted to create an entirely new, different substance.
So, we did it. We used empirical data to find the exact combination of ingredients, and we used the scientific laws of physical properties to prove that a brand new substance was born in that water. But, as with all great science, answering one question just opens a door to another. We proved a new substance was created, but exactly which gas is trapped inside those bubbles? Is it oxygen? Carbon dioxide? Something else? Well, that is an even bigger puzzle, and exactly what we'll have to investigate next time.